So let's look at this question quickly. A current of 5 amperes flows through a wire in 4 minutes. Calculate the number of electrons flowing in the wire per second. Per second. Okay, so from the equation of the quantization of charge, we have using the equation of quantization of charge. Quantization of charge, which is Q is equal to what? NE. Q represents charge, N represents number, E is the what? Elementary charge. This question is not asking us about the number of charge in the wire, it's the number of charge per second. So we have Q is equal to what? IT is equal to what? NE. What is I? I is what? 5. What is T? 4 minutes. That's 4 times 60 seconds. Is equal to what? NE. Okay? So from here, we can easily say that this is 20 times 60 is equal to N. What is N? N is what? The number of charge. Is elementary charge. 1.6 times 10 power minus 19 coulombs. So this equation will give us the number of charge that is flowing in that what? In that wire. Is that okay now? So in order to get the number of charge flowing per second, we have to divide this thing by what? 4 minutes, which is 4 times what? 60. So I can say that 5 is equal to N over 4 minutes, which is 240 seconds. Will give you the number of charge flowing in 1 second over E. So it simply means it's solving times E, which is times 1.6 times 10 power what? Minus 19. So in this particular question, you don't even need to substitute this, because what you are calculating is not just the number of charge, it's the number of charge flowing per second. And the time taken for this current to flow is 4 minutes. So this is what we are solving for. So I can just replace everything there with N over T. So 5 is equal to what? N over T times 1.6 times 10 power minus 19. Therefore N over T becomes what? N over T becomes 5 times 5 over 1.6 times 10 power minus 19. And this will give you 3.125 times 10 power 19 charge per second. Okay? So that is that. That is that. Okay. That will give you the number of charge flowing in 1 second. So the number of charge flowing in 1 second actually depends on the current and not the charge. So if you take this thing, you're going to have number of charge flowing per second. That is per unit time. So the reason we have included this 240 seconds is for you to know that the total time taken for the current to flow was 240 seconds. But what you actually need is number of charge flowing in 1 second. So instead of solving the question in 2 stages, you first use Q is equal to IT to find N. You now then divide again by 240. You have solved the question in 2 stages. It's going to take a longer time. The number of charge flowing per second is just dependent on the current and not the charge. Okay? But the number of charge flowing, the number of electrons or the number of charge flowing depends on what? On charge. Remember in this question, you are calculating for the number of electrons, which is the number of charge. So the number of charge flowing depends on the quantity of charge. That's the number of electrons flowing. Depends on the charge. But the number of charge flowing per unit time depends on current. That's why it's like that. So we take the second question.